Hi, I'm Polyglot Dan, and I know many languages off and off the JVM. All right, here you go. And I'm Skeevy Dan, and I only know Java. All right. Knowing new languages lets me discover a lot of new and different things that I could also use in Java when I decide to use Java. And I know design patterns. All right. I have a vast number of tools at my disposal, a lot of them that have nothing to do with Java, and that makes me more productive. Let me write that in Java. All right. Knowing all 5 different languages on the JVM makes me more desirable for customers and employers, so it makes me more profitable in the end. Scala and Clojure make me dizzy. All right, so there's my commercial. And while they're trying to fix the VGA here, I could try to do as much as I can just to talk about what my central theme for this particular talk is. It's learning the 5 new JVM languages, or not new, some of them are pretty old, but learning 5 JVM languages within the next 5 years. I notice a lot of speakers out there usually do a talk that tries to change people, and I thought, I don't like to do that. I don't like to intrude that much, but I thought I'd try my hand at this one because I think it's a good idea over the next 5 years to think about some of the new ideas that come forth with a few of these JVM languages. So I'm going to dare all of you to learn. You ready? Java 8. I mean, I know you use Java, but Java 8 has changed a lot of things about the way you think about using a language. That's the first one. The next one, Clojure. The next one after that, well, it could be in any order that you want. Definitely learn 5 new languages in the next 5 years. The other one, let's see, Clojure, Scala, JRuby, and Groovy. So let me just poll the audience. How many of you know Java 8 now? Okay, small fraction. It looks like it's getting there. How many of you are bound by your employers to a certain Java version, usually because of licensing restrictions? That's amazing. That's a fairly good chunk. So Java 8 changes a lot of things about how you design software, particularly the use of lambdas. I have another talk called Walking TDD. I'm not doing it at this conference, but it's based off of David Heinemeier Hanssen's blog post that TDD is dead. And Rubius, what are you going to do? They're all claiming things are dead. They claimed like 10 years ago that Java was dead. So they're always doing that. So he declared TDD is dead. We'll never be using TDD ever again. We'll just stick with system testing. And during a YouTube chat about whether TDD is dead, David Heinemeier Hansen kind of like backtracked a bit. Kent Beck was there, the TDD proponent, and so was Martin Fowler. During that particular podcast, Kent Beck had mentioned, I don't do mocking. And I thought, wow, that's weird. He doesn't do mocking. And that was like plaguing me for a long time. Oh, is VGA back? Working as well. So I'll continue my story. So he said, I don't use mocks anymore. And I think some of you know what mocks are. And I thought, wow, this is really racking my brain. Why is it that he doesn't use mocks? So I started thinking about it. And really the answer is to use functions. To use functions as a first-class citizen, and you can manipulate your language to do whatever it is you need to do. So I thought that was very interesting into itself. And that's going to be probably the biggest highlight for Java 8. And it's going to be important to understand that kind of functionality because other languages already have that other kind of functionality. In Groovy, how many of you know Groovy? That's a small percentage. I'm surprised by that. Groovy is actually a beautiful language. We had a talk at another conference, Birds of a Feather, and someone had mentioned the only thing wrong with Groovy is likely the name. It sounds like something that you need to be in a drug-induced coma in order to enjoy and be productive in. But it is actually a great language. It is dynamically typed. And out of all the other languages in the JVM, that's the one likely with the lowest learning curve. The idea behind Groovy is that you should be able to take Java code wholesale, take that code, rename the file .groovy, and you should be able to compile it in Groovy. By compiling it, it just compiles to the same bytecode. Or it's interpreted. You could just run regular Groovy code in the interpreter. So it's a great language. It's an easy language to learn. Some of the things that I particularly like about Groovy is it makes making lists, making sets a whole lot easier, making maps a whole lot easier. So it's definitely a language worth a try. I'm going to assume that if you ever take one of these languages on, I think that one's probably going to be probably a 6-month type of language. In fact, if you're going to choose to start your venture on learning some of these 5 languages in the next 5 years, I think Groovy is going to probably be the quickest one and the one you're going to enjoy right off the bat. Okay? But I'm still daring you to learn all 5 of them. So that's Groovy. It's actually dynamic typing or static typing, meaning let's take in Java you have string A is equal to some sort of string. You could still do that in Groovy, or you could choose just to do def A, hand signal code. You could just do def A with some sort of string or some sort of list or some sort of object along with it. So it's a really nice language. You can choose to whatever types you want. They have closures, which are functions within Groovy, and it's an excellent language to work with. The other one is JRuby. And you're probably thinking, gosh, what JRuby, where'd that one come from? I think this one, I'm placing my bets on this one. I think it's going to be useful because of all the wonderful tools that you can use with it. Currently I use, if you ever saw my slide deck, I use a tool called Asciidoctor. It's a way for me to use any editor to create slides right off the bat. It uses JRuby and Java in the back end to create my slide deck. I never have to use a PowerPoint or anything like that because it takes too much time. I'd rather just type my slides out and render them. So I'd be amiss of all these great tools if I didn't know any of these extra languages. I could actually manipulate Asciidoctor to whatever I need. There's another build tool called Builder. I don't know if any of you heard of Builder, Apache Builder. It's B-U-I-L-D-R. It's a wonderful build tool. A lot of developers do enjoy that, but that's all Ruby based. It's an entire build tool based on Ruby. So there are a lot of great tools, and not only that, you can also use JRuby with a lot of tools that have already been developed under Ruby. A whole swath of great frameworks like Ruby on Rails that have been developed in the Ruby language, you could also use within the JVM. So I think for some of you, you're going to enjoy JRuby a lot. There are a lot of great tools along with it. I think probably as far as learning Ruby, Ruby takes on a different style, but I think you'll probably be looking at 7 months to understand the language. And when I say learn these languages, I'm not talking about a really in-depth learning of these languages. I am talking about knowing these languages, know what the capabilities are. So in case you're in a pinch or in some sort of emergency and you're using these tools, you'll know how to get in there, change whatever you need to, design whatever you need to, and get out. So I think that's going to be a very valuable asset in learning JRuby. The next one is my favorite one, and that is Scala. I really, really love Scala. I'd rather call that one the next Java than Groovy. The reason I like that is because, like Scala, is because it's very concise, it's very beautiful, it's a really great language, and it's static type, very much like Java is, with less typing. And the reason why there's less typing is because everything is type inferred. I don't have to explicitly declare everything because the compiler is going to work on my behalf. That is the absolute greatest thing about, or one of the greatest things about Scala. I can manipulate a lot of things within the type system as well. So it's a very powerful language. One of the things that a lot of people state when discussing Scala is that it's a very hard language. And to that I'll say, oh, okay, yes, you're absolutely right. I liken Scala to a crane. Now, if I told you, all right, here's a pile of cinder blocks, and I want you to take these cinder blocks and put them up to the top of the roof. So you have two options. One, start lifting up the cinder blocks and go up the stairs with these cinder blocks one by one, or maybe if you're really strong, two at a time. That's certainly one option. But of course, the other option is learn how to use a crane. Now, there's some learning curve to learning how to use a crane. You have to learn about weight, you have to learn about safety, you have to learn about wind, you have to learn about tension, you have to learn about the mechanics of the crane. So you have a lot to learn about it. And very much like Scala, you have a lot to learn about the language, but it will pay off in dividends much later. Scala is likely going to take you, I don't know, probably a year and a half to two. It's actually a more difficult language to learn, but it is definitely worth the investment. Okay. As far as Scala tools and a lot of killer apps that are there within Scala, you probably heard of Akka. Akka is an actor system that allows you to do concurrent applications either on the local VM or on a remote VM. And the way that works is you send messages to these actors. They get placed on a queue. A thread is dispatched to them, and it's able to make your computations or whatever you need to do asynchronously. So that's a great framework that you can use. Let's see, the other one is Play Framework. Play Framework is the web framework that is available in Scala, a very popular web framework. Should I say very easy to use? No, maybe not. I mean, every web framework has its own little difficulties. So on the Scala side, there are a lot of great applications that you can use. I'd hate for you to be remiss of all that potential. Clojure is another great language. In fact, I think that's a really beautiful language onto itself. And Clojure is a Lisp language, a Lisp processing language. It is very much exactly like Lisp, plus or minus some features, particularly features that you don't have to use as many parentheses as you do with the original Lisp. This one I learned in about 6 months. I already had some experience with Scheme. I would say about 6 or 7 months you'll probably get the core idea about how Clojure works. I would say, and this is just purely opinion on my part, I would say that Clojure is beautiful if you do a lot of data processing. And the reason is the language embraces pure lists, pure vectors, pure sets, and pure maps. And you wrangle the data using some of these pure constructions. And it's a functional language, very much like Scala is. Both Scala and Clojure embrace immutability, meaning that if I were to describe it in POJO terms, if you create a POJO, you don't have any setters, and all the member variables are final. So both of those languages embrace immutability. It allows you to reason a lot better what you're going to get in return using some of these languages. Well, I can't believe I haven't been using slides all this time. So I think you're going to, some of you are going to enjoy Clojure. And what some of the killer apps that you will see with Clojure. One of them is Datomic, and it's kind of an interesting project. Take a look, it's DATOMIC. The idea behind Datomic is, let's take, for example, a relational database. And you want to change the data. What happens? Well, you actually overwrite the data, right? I think for most SQL stores, you take a column and you change that data, and all of a sudden that change you made overrides whatever was there before. Now, think about version control going out for a night drive with a relational database or any kind of database. And they get along with one another and they have kids. And those kids are called, or one kid is called Datomic. So with version control, if you change a row in a database, you have not only the current information, but all the changes before that. You have the version control behind it. I think that's going to be a really huge app. in the future. I think it's going to change the way we think about data stores in general. So that's a really big app to look for as far as Clojure goes. The other one's a Clojure script. So there are languages that compile to JavaScript, and Clojure script happens to be one of them. And it seems a lot of Clojurists really want to push that idea. They think they really have a really good solution as far as a JavaScript type language that is developed obviously in another language. So look out for that one for Clojure. And without slides, my brain's kind of keeping track of like where which one am I missing? I got JRuby. Oh, Groovy. So Groovy is now an Apache product that was announced last week, I think, or even just a few days ago. Groovy used to be a part of Pivotal, but Pivotal no longer financially supports the Groovy language. So now that's over at as an Apache incubator project. And Groovy's been around for quite a while. It was first developed in 2003 by James Strachan. And the language has been very popular for the last few years. Again, I think it's kind of a shame that people don't use Groovy as much as they should. It is a very compelling language. It is expressive, meaning that whatever you wish to express in code is easy to do with Groovy. And there are some killer apps. One of them is Gradle. How many of you use Gradle as a build tool? Okay. Oh, okay, still a small fraction. So Gradle has, how many of you use Maven? All right, Maven is still pretty dominant. So Gradle, so what's wrong with Maven? So Maven has a lot of XML. And in order to do something flexible with it, you need a plugin for it. And you kind of have this need sometimes, and I'm sure all of you feel that when you use Maven, that you wish you could script some of this stuff that's within the build tool. So Gradle has that. It has a lot of the Maven plugins and different things like that. But it also has the ability to script things out just so you can get that flexibility. It's a wonderful build tool. Take a look. And probably that's one of the best ways to learn the Groovy language is to make that a part of your build. So Gradle is one of their killer apps. The other one is Grails, which obviously was inspired by Ruby on Rails. It used to be called Groovy on what was it? It wasn't Groovy on Rails. It was called Groovy on Grails. But the Ruby on Rails folks decided to make a complaint about it, so it's now just Grails. You could download that framework from grails.org. How many of you use Grails? Okay. Now, the wonderful thing about Grails is that it has a quick scaffolding. So you just quickly say what it is you need in a website, and it generates a whole hell of a lot for you. And all you have to do is just tweak the minor elements. So that's another great thing you're amiss of if you do not use anything in Groovy. So take a look at that. So let's see, Gradle, Grails, and I know I'm missing one. I forgot what it is. There's Spock. Spock's a wonderful testing framework. I don't think I'll ever get this. No, it's not even up yet. Yeah, please, go ahead.
Why don't you bring your laptop to compare directly so the
Okay. Yeah, let's see. How much time do I have? Yeah, let me think about that. Is that a possibility? Do you know? What's that? Yeah, see if we could just directly attach it to there. Is that okay? All right, we're gonna find out. That's a great idea. Thank you.
Also, if you have your slides, you may need to send to us. We can download them and have one local.
Yeah, okay. Let's see. Where would I? That's an interesting scenario. So let's see here. How about I do? What's that?
Can you state the scenario so we can hear it?
State the what?
Could you repeat what he said? What's yours?
What he said? To make a PDF and just post it somewhere, and then we could just all share, since mostly everyone seems to be sharing a device, so we could use that as a workaround. Give me a second here. Whoa.
All right.
There we are.
Your laptop is on extended mode, that's why the video is not even.
What was it?
It's on extended mode, that's why.
There we go. All right, so there's my Roblo one here, all right. Okay. So, when I did my commercial, there's what I was talking about rejecting other ideas for other languages. Now, I should have been able to do a shared mode on the screen here, but there we go. All right, so let me continue with my presentation then. Pick up this book. This is an excellent book called The Pragmatic Programmer. And if you've not read this one, it's a very great book, and it tells you about learning a new language every year. And it's changed the way I think about a lot of things, and the way I do programming today. So I learn a new language every year. Just like they said, I have a scripting language that I use. I use either Ruby or Groovy now. Use that as your particular workhorse. Know as many languages as you need to. Know your IDE very well. And choose an editor that you know very well. So both of mine are Vim and IntelliJ. Those are my two favorite ones. And again, of course, learning a new language every year is extremely valuable. So these are the languages to learn. So Java works very well. It's a very well-cultivated language, and it brings us the money. And so Lambdas in version 8 change the nature of the language and how we work with the language. And it brings us up to par with what other languages have had for quite some while. So learning some of the block and lambda constructs in the other 4 languages, you might find that the Java 8 way of doing things is a little verbose. But are we to blame the Java engineers for all this kind of verbosity? And really, the answer is no. So Java is a language that we've had since 1995, and they try to make sure that everything is backwards compatible. And because of that, they have to make sure that everything they do is taken with care. And to retrofit it with some of these advanced features is something that they cannot take lightly. So they did so without breaking the core of the language and how we understand that, and I think up to this point, it's been a very good language for us. So let's take a look at some of the ways that we do functions with Java 8. So some of you mentioned you don't use Java 8. Some of you may have seen this before, some of you may not. So here's an interface with my predicate of generic type T. This is just a regular predicate with a Boolean method called apply, where we get some kind of argument of type T. So given this now I know this is already built into the language, but let's say I wanted to create my own particular predicate. So I have a method called myOwnFilter where I'm bringing in a list, and I'm going to bring in that particular predicate. Now with this predicate, there's an apply term on here that I can just decide whether I can filter something out or not, given a particular iterator. And then at the end, I'll just return the new results as a copy. Okay. Now, I can call my filter with the implementation, and we know this by our anonymous implementation. My filter with an arrays, and then I could just create that anonymously with a new predicate of integer, where we apply that one integer, and I could say, filter everything that is an odd number. Okay? So this is up to maybe Java 7 without using the lambdas. But here's a rule about Java 8 lambdas. It's a functional interface that if you have one abstract method, you could have default methods or other static methods, but because it contains one abstract method, you could omit the name when you need to. Now, this does not include equals or hash code or anything that comes from Java Lang object or anything else inherited. So that's the definition of a functional interface. And as you can see here, there is only one abstract method, and that one's apply. Okay? So can we use this? Absolutely, of course we can. So given this now, what I could do is I could take my filter, give it with provide it with a list, and then with that list now, this is the same as that anonymous class instantiation that I had. Okay, so this is lambdas as we know now with Java 8. Okay, but predicates and filtering are already built in with a catch. And here's the catch. So if I have an arrays of 1, 2, 3, or 4, and what I have to do in order to use a filter, so in this case here, I'm using the filtering mechanism that comes with Java 8. And in this case here, given this list, I have to call a stream in order to filter it. And what I'm going to get after this is a stream object that I then am going to use to filter that particular list. So this filter says for every element that is in this particular list, filter out everything that is not odd, okay? Problem is, at this point right now, if you do a print line of this or a class name to figure out what's going on inside of it, I'm going to get a stream object called a reference pipeline. And that's kind of useless to me. What I want in return is the filtered list. So what do I have to do is I have to create a collector if I want to, but that comes at a cost. Here are the abstract methods for that particular collector. I need to implement an accumulator, characteristics, combiner, finisher, supplier, and that's too much work. So, thankfully, there are prefabricated collectors that I can use along with Java 8. So in this case here, I have a list with a stream filter, and I'm going to filter out all the odd stuff, and what I could do is say, okay, now I have a stream object. What I'd like to do is recollect that again as a collection. So what I'm going to do here is recollect everything as a list. Or I could just do this as a custom collection. So on the bottom side here, what I have is I have arrays as list, stream filter. I'm going to filter out all the odd information. And then finally here, I'm going to collect everything onto a tree set. So if there isn't a collection that I particularly like and I want to create my own collection, that's what I'll have to do. This is kind of verbose. So thankfully Java 8 has lambdas, but still it comes at a little bit of a cost. I have to collect everything again. So I could do my filtering, but I'm going to have to place a collector there to collect it again when I need to. So Java 8 is wonderful. You're going to get a lot of mileage out of it. But like I mentioned, there's still going to be a lot of typing along with it. So this is a lambda in Groovy. It's called a Clojure with an S. Clojure C. And in this case here, we just create a block that will take an X, and given that X, whatever X is, if there happens to be a modulo method on that particular X, I can ask whether this is odd or not. So given this closure, I can do a filter, but in Groovy it's called a grep. But there are no collectors. It's very simple. If I have a list of 1, 2, 3, 4, I can just call grep with that particular closure, and everything works as expected. I could also inline it, okay? Very clean, very easy. If I have a list, by the way, I don't have to do a new array list or anything like that. If I just want to create a list very quickly in Groovy, just 1, 2, 3, 4, grep, and inline I have a x modulo 2, and I determine whether I want to filter out all the odds or evens. In this case, I'm just filtering out all the odds, and that works as expected. But they have this really neat keyword called an it, and what this means is that in that block there, that closure, we're going to iterate through everything in the list and filter the things that pass or the things that don't. That block has to be a Boolean, so it's going to go one at a time. So it's going to do 1, and 1 is going to be it for the first iteration. Second time around, 2 is going to be it for the second iteration. So this is a case where I don't want to come up with a variable name if I don't want to. Okay? So very easy, very concise to work with. I could also collect. Now, collect may be known as map in other languages. So if I have a list, I can call collect. And in this case, what I'm going to do is I'm going to multiply 3 to everything that is already onto that list. Okay? All right, so let's take a look at another neat feature. This is collections and mutability in Groovy. I am importing Groovy transform. That's going to allow me to do a canonical. Take a look at that class there. That's pretty nice. So by doing an @canonical on this particular class employee, this is going to create some getters and setters for me. It's going to create hash code. It's going to create everything that I need. So let's say I'm creating a stack of employees. So this HW new employee, I'm going to create Handsome Wonderful, and Handsome Wonderful makes $40,000 a year. I'm going to include him in a list. I'm going to include Sarah Stylish and Sylvia Sleek. Both of those ladies make $50,000 and $80,000. So one of the things that I could do is I could do something like this. Employees collect, which means that I'm going to do the following and apply it to every one of the employees in this list. So every employee on this list, I want to take their salary and I want to add $10,000 to those employees' salary. I'm very generous. All right, so given that now, that print line is going to return the values of those salaries, $50,000, $60,000, and $90,000. But if I print the list, what we'll see is that, or if I print the object, so in this case here, I'm printing out the object for Handsome Wonderful here, and we'll find out that he has received a $10,000 raise as well. Now, I'm not sure I'm comfortable with this, but maybe you are. This is a sign of mutability in the language, and sometimes you will get some surprises. I don't like these surprises that much, which is probably why I don't stick with Groovy all that much. But if you're comfortable with this and you think of this as more of a feature, then Groovy is the language for you. So as you can see here, the actual object itself has mutated as well as provided a list. Okay? So there's also a spread operator. So this is the spread operator. These two, the last slide was synonymous with this one. It's called star dot, and it's the spread operator. And the spread operator allows me to apply something to a list. So give me the entire list of employees, and for every employee that's in there, I want to change the salary by adding $10,000 to it. Okay? Now here's JRuby. So JRuby has 3 different forms of functions. So what I'm showing you here are all the different forms of functions. There are blocks, procs, and lambdas. But I couldn't find an image for a proc, so I decided to use a croc. But that's the idea here. All right? So here's a block in Ruby or JRuby. So given an array, so JRuby does not have lists, they have arrays. So I'm going to do an array select, and select allows me to do filtering. And this is just one way I can do this. I can use a do block, and for each X, I want to determine whether this is odd or not. Or the other thing that I could do is I can use this sort of block. Okay? These are blocks, and it makes the programming language very concise by using some of these blocks. Now, how do the blocks work? So let's take a look at this example here. So I have, in this case, I have def, which is the way we create methods in JRuby, and I have a call block. Within this call block, I have a call to yield. So this means for whatever block I receive within this method, I'm going to yield the information onto that block. So in there, I have yield with the string hello and the number 99. So if I call this method call block with this block, I have string number. And so when I yield hello and 99, string and num in this particular call right here will be replaced with hello and 99, puts as print line in JRuby and Ruby, and what this is going to turn into is that I'm going to print out hello with a space, and that number I'm just going to convert to a string. That's their method of doing so. Okay? So that's one way to do it. The other way is just to do it in line just like this. Call block do with the arguments and print out the string. Okay? So as you can see here, a lot of things kind of stay the same even though we're using different languages. Okay? So I could do multi-line if I want to. It doesn't have to all occur on the same line, and I could just keep going if I need to. Okay? So JRuby is very easy. So there's also procs. So here's the situation. Right now, this does not work, or it never does work in Ruby. If I have a call block and I have a yield, all that doesn't change. I can't do this. Like, I can't assign a block to a variable and reuse it multiple times like I have on those last 2 lines. It should, but it doesn't, because blocks don't work that way. So what we need in turn is we need to use either the and block there, and what that's going to do is it's going to convert that into a proc for us to use. So they have different ways to do this. And so what's going to happen here is that this is going to turn this particular block into a proc object so that we can use that. So now we can do a call block with either one of those and bring those in. And because of that, what we can do now is we can do a, instead of a block like this, which didn't work, we could do something like this. So a proc is something that allows us to convert a block to something that is an object unto its own and that which we can reference. So this proc here now, I can assign it to a variable, and now given that variable now, I can call this method with that particular block. Okay? So that's what a proc is. Proc is something that is going to be an object that I can reference and that I could send to a method. So JRuby and Ruby also have lambdas. So here's a lambda. This is def lambda method. And within this method, I have this call called internal lambda. All I have to do, what's really nice about JRuby is I don't even have to put a def or a val or anything like that. I just, if I want to make an assignment, I can make an assignment like internal underscore lambda and assign that to some sort of value. In this case, lambda return 4. So this is just going to return 4 from this particular lambda. So if I call this lambda, one of the nice things that this will do is that it will print out starting, it will make the call to this lambda, print out 4, and it would also continue along with the rest of the code. The others do not do that. So that's going to be the difference between a lambda and procs. So this is what a proc looks like when it's returned. So take a look at the difference between this and this. So as you see here, the lambda keeps going down the stack. Starting, we'd make the call to that internal lambda, which brings us 4, and finally we have the ending. Okay? Now within here, this is a proc. So if I make a call with, or if I create the proc on the first line inside of this proc method, will print line a starting, and then what we're going to have next is we're going to make the call to this particular proc, at which time all we get is starting and 4. So procs in Ruby will always return, whereas lambdas will return but will continue down the stack. So those are the two differences. So that may be probably the most complicated thing as far as Ruby is concerned. To me, that may be a little bit shaky just to deal with on a day-to-day basis. But the rest of Ruby is a great language to work with. So in this case here, I'm doing a proc with string interpolation. So given an x, y, z, I'm just going to print out x is x, y is y, and z is z. And when I do that, call read block, given a proc, that block call will provide information. So in this case, what I have here is I have block call 4 and 3. But take a look at this. Right here, I'm accepting 3 arguments. So one of the things that you can get with a proc is that it has no problem doing this. All it's going to do is just omit the z. But lambdas, on the other case, if I call this read block with a lambda, I'm going to get an exception based off of that. Okay? So they have really weird rules when it comes to functions, and you would have to deal with that. So they have 3 different ones, and that's up to you if you're interested in that sort of thing. Now, Clojure. This is what I mean that to me, I think Clojure is a very beautiful language. So take a look at this. This is how we define, they call this a function, def end function. You could think of it as a method if you like. Def end will say, so average is going to be the method name if you want to think of it that way. What comes next is a vector of the different variables for this particular method or function. So in this case here, it's going to be numbers. Now, Clojure is dynamic typing, so numbers can be anything. So in this case here, what I'd like to do is I'd like to apply addition to all the numbers. So what that's going to do is it's going to apply addition to everything. So it's going to accumulate all the numbers. On the second group here, I'm going to take a count of all the numbers that are available. And of course, I'm going to divide. The thing is, when you start to learn Clojure, is that the operator is here on the left-hand side. Okay? What I'm doing here with this apply is I'm actually calling apply with two arguments. One's the function, and the function's called it plus, and the second argument is numbers. Count, so you're very much used to saying, like if you have a list, list.size. In this case, you do count is on the first one, because that's what we want to operate on, and numbers is going to be synonymous with the object or what you want to operate on. So if I provide it with an average of 1.0, 3.0, 10.4, 11.5, that will work just fine. So here's another one. So take a look at this one. I have def n op. So the name of the method is op. And I have f, a, and b. And f, a, and b could be whatever it is. And as long as it makes sense semantically, it's going to perform whatever it needs to do. So what can I do with this? Take a look at this. I'm sending op, so in other words, I'm calling op, the method. I'm providing it a function. This function takes two numbers. And a is going to be 4, and b is going to be 2. Given that now, what I can do is provide that plus here where it has the f, and it's going to perform the operation whenever need be. So the thing I really like about Clojure is that you are forced to think about higher order functions. Whereas other languages are like, you don't have to use functions if you don't want to. You can go about it your old way. But Clojure is going to force the way you think. And I think this is going to have a very positive effect on the way you do development. Here's an inline anonymous function. So I'm going to call map, which is actually the correct functional name to do this kind of operation. Inline, I'm going to have this term fn with a vector of I, meaning that for every I get, I want to take that and multiply it by 2. This is kind of, when you think about this, this kind of looks like your old HP calculators with the reverse Polish notation. Same thing. So, given this I, so for every I that's coming in, I wish to multiply it by 2, given this vector, 1, 2, 3, 4, and 5. And in return, what I'll get is 2, 4, 5, 8, and 10. But I could rewrite that. Very much like it in the Groovy, we have a %1, which means for that first argument that comes in, I want to multiply it by 2. The hash just means that this is the same as an anonymous function. So this is an anonymous function that will multiply whatever comes in by 2, and we get the same thing. Okay? But that could also be written like this. So this is a map with an inline function. Multiply, remember, the thing that's on the left-hand side of the paren here is going to be the function. Okay? So in this case here, what's happening is I'm going to multiply whatever comes in, whatever argument comes in, and I'm going to multiply it by 2. Okay? Very simple. Scala, my favorite language. So here's a function in Scala. So given an int that's coming in, I'm going to take that int and decide whether this is odd or not. So I could take that f. We have the way we declare variables, we have two things. We have actually values and variables. This val right here means it's a value, meaning it's analogous to final in Java. So val just means it can't be changed at all. Var means that it can be changed. So given this now, for every int that I get, I'm going to determine whether this is odd. I can take that f and place it inside a filter. I could also do this. This is just another way that I can create lists in Scala. This comes from Haskell. So whenever you deal with Scala, you're always going to ask yourself the question, where the hell did this come from? And generally what the answer is going to be is it's either coming from Java or it's coming from Haskell with maybe a little bit of Erlang here and there. Okay? So given this list 1, 2, 3, 4, and nil, and again, this is the Haskell way of creating numbers. What this means is nil is actually an empty list. And then what we do, these are right associative. So hold on to your hats here. Some of you may be like, oh, I don't like this. All right, so the way this works is nil is an empty list, and 4 is going to be applied to nil backwards, because it's right associative. So we're going to have a nil, then it's going to be 4, 3, 2, and 1. Okay? So it's going to create the list of 1, 2, 3, 4, and I'm just going to filter with that particular filter. That's just one way we go about it. We could all make this inline. So list 1, 2, 3, 4 dot filter. For every X that I get, I just want to filter out all the odd stuff. Or I can use type inference. So because I have type inference, it knows that the types that are inside of this particular list are of type int. So I don't actually have to declare it. So right under this filter here, I can just bring in X. Scala already knows that I'm dealing with ints, so I don't have to actually explicitly declare it. Finally, just very much like it in Groovy, and very much like, what was the one I just talked about, Clojure, has the %1 or the %. I can do this. That underline is a placeholder. It's very much like it, okay? So none of this, when you take a look at this in the context as in multiple languages, it's not so scary after all. So we know about Java lists, how we create Java lists. It is rather verbose. I mean, we could either do a new array list and call add, or we can do an arrays as list. So if I want to add a few new employees, I could just do something like that. Still a little bit verbose, but it's getting better. You could use a great library like Guava to make this a little bit less painful. But there's a lot of verbosity going on in here. Sets, we know how to do sets. We just have a set. If we have a set of employee, we create a new hash set of it. Again, we have add. I don't think there are any helpers for creating sets or maps very quickly, so unless you use Guava. So in this case here, here's our Java maps. So we know how to do all this, so I'll just dispense with that. But here's a list in Groovy. Ta-da. When we create variables, we just call def, the name of the variable name that we want, and just create the list using brackets. Okay. This is how we create maps. Where's the set? Oh, there it is. Here's a set. 1, 2, 3, 4 as a hash set. Okay? Very quick and easy to do. You don't have to spend that much time typing. Here's arrays. So JRuby and Ruby use arrays. They don't use lists. That's what they call it. But the idea is the same. And again, as opposed to like Groovy, you have to have a def in front of it. What's nice about Ruby is you just say A is equal to blah. You don't have to waste that much time. Here's how you do a set, very much, nearly like what Groovy does. If you have an array, you just call toSet and you get a set out of it. Or you could just call set.new. By the way, when you do instantiations in Ruby, it's kind of the opposite. You say the type.new. So if you create your own employee class, you do employee.new with whatever parameters that you want. Here's a hash. They call it a hash, they don't call it a map. But the number 1, if I have a key of the number 1 and my value is a string, that's the way I do that within Ruby. So here's a Scala list. I already told you about Scala List and how that works. Here's a set, and it's very easy in Scala. And here's a map. So what this is actually is a map is a collection of a list of tuples. So tuples is ingrained in part of this language. So a tuple is something with 2, 3, 4 items. It's a heterogeneous container. I wouldn't even call it a collection, just something that stores stuff. So the way this works in Scala is a map is going to contain 0 or more of these tuples, and that's the idea of what a map is and how everything is contained within that map. So here's a list in Clojure. Now this isn't something that Clojurists typically do. They do have a list, and you can do something like this. That first one is I am defining a variable. We define variables in Clojure using def. And in this case, I have a variable name called a list. And the operation is called list, which is going to generate a list out of the following arguments: 1, 2, 3, and 4. That's one way to create a list. The other one is to use that quote. See that little tick mark right next to it? That's the same thing as what you see above. This means create an actual list. And Clojure has this thing called a reader, which will see that quote and say, okay, I'm not going to evaluate this yet. I'm just going to pass over it. Okay? So that's what a list is, but Clojurists do not do that. What they do is they just use a bracket, and this is actually a vector, and they make a they always distinguish between a vector and a list. So if I were to make a vector of states, then I would use the bracket. Take a look at this. This is one of the greatest things that I wish was implemented in other languages. Do you notice something missing from here from how you create lists? Something that's usually very annoying, but you don't even really think about it? Commas. I don't have to use commas as far as constructing this. I know it's a small thing, but man, just comma, comma, comma. Sometimes when you forget that comma, it's a really big pain. And so Clojure, they just said, nah. Why do you need that? Just continue go. Here's a set. Sets have a hash in front of it, but that's the way you define a set. Very easy, and you can see a lot of these languages, you're missing out on a lot of things. So if you're just stuck with Java, imagine your life just creating simple sets like this. Here's a map. I forgot the names of these are. These aren't, in Ruby, these are symbols, but I forgot what these are called in keywords. Are they keywords? Okay, these ones right here I'm talking about. Okay, so these are kind of like intern strings in Java. They're meant to be keys in a map. So in this case, I have National League. I have Reds, which are Cincinnati Reds, Dodgers, Braves, Atlanta Braves, Astros, and Expos, which is nil because they don't exist anymore. But this is a way you create a map. So very easy to work with. I have a variable name called National League. By the way, Clojurists do not use camel case. They use typically all small letters with a dash. That's usually their convention. But very easy to reason with. It's really not that hard. So classes, I'm going to have to rush for because of the issues we had earlier. But take a look at this. So this is Java classes, not particularly Java 8, but just Java. Venkat Subramaniam, another speaker that's here today, calls this vomit. We have to vomit a lot of code to just get something simple done. And I have to do a first name, last name, list that as private. I have a constructor and I have a setter, I have a getter. I need to do my hash code, my toString. That's a lot of work. Here's what it is in Groovy. Canonical, use that annotation, and it'll provide everything else for you. And all you have to do is just do a def first name, def last name, you're good to go. Okay? You've been wasting your life all this time. Here's Ruby. This is the long form. That initialized right here is the constructor. Take a look here. One thing about Ruby is that there's see that single @ sign? That's a member variable. But we don't have to declare member variables in Ruby or JRuby. That @ is all you need. And what it's going to do is it's going to create a member variable right off the bat. Okay? I'm creating a getter and setter called first name and last name, which is going to return that member variable. ToS is toString. Equals is the double equals, and we just match that with a other. By the way, here's what I like about JRuby and dynamic languages. I'm still a big fan of static languages, but this right here, if you could get away with this in your life, all the better for you. I don't have to do is instance of. It's dynamic typing, so as long as this other has a first name or a last name, I can do this match. It's called duck typing from the term, if it looks like a duck and it quacks like a duck, then it's a duck. Or as Shaq likes to say, or a chicken that does a really good impersonation. All right. All right. So I can actually refactor this down by a lot. So remember I had this getter for the first name and the last name. I can also have an attribute reader. So that's just going to create the quote-unquote getters for me. Here's the writer that's going to provide the setters for me. But if I want both getters and setters, I could just do attr accessor with symbols, the symbol for first name and last name. And all of a sudden, I don't have to do that much work. Here's Scala. Here's the first implementation for that. That's a lot of work. This is ugly, mutable Scala class that does the same thing with pattern matching. But I can bring this down a little bit further and even further. Now, note that how awesome this is. In Scala, all I do is to case class employee. The type and the variable names are interchanged. So first name is of type string, last name is of type string. That's it. Everything else is already done for me. My toString, my equals, my hash code, all done. Clojure classes now, when you decide to learn Clojure, this is going to be a little bit different for you. They don't do a lot of OOP. Clojure is a very functional language. They do bring out objects whenever they need to, but on a regular workday, most don't even think about doing types. They think about just, and this is the thing I like about Clojure community, they think about lists, they think about sets, vectors, and maps, and they manipulate data just on those 4 levels alone. Okay, so you have 5 different things that you can do, but mostly what they do is they use maps as models. So if I have the employee of the month as Milton Wadhams, if you know who that is, good on you. And what you could do is you can just use the key to bring out whatever it is you need. So if you want the first name of the employee of the month, there it is. It's easier to reason with maps than anything else, and that's what Clojurists like to do. The other thing too, take a look at that. I could even interchange them, so I could have employee of the month. So what I'm doing there is I am feeding the map, and that map is actually a function, and I could give it the key. Okay, so you can do a lot of creative things with that whenever you need to. Now they have def records. Def records are a way to create classes. So in this case here, this will actually create a class called employee so that I could call that from Java if I need to. And that's a def record. It behaves very much like a map. The other thing you do is you could do a type as well. You would have to hard code everything because it provides no added functionality. But you have that available for you as well. So in case you do need a class and an object along with it, you can use either one of those. But again, Clojurists usually don't do that sort of thing. They usually just stick with lists, vectors, sets, and maps. Apps and libraries. Obviously, Java has a lot of apps and libraries from Apache, Google Libraries, Spring Framework, Android, so you have a lot to look forward to. But now with Java 8, you can use functions. Groovy, you have Grails, Gradle, Spock, a really good testing framework. You have Builder, Asciidoctor for Ruby, and as well as other Ruby developed applications. Scala products. Apache Spark is making waves. It is a functional layer that is on top of Hadoop. That's become extremely popular within the last year. Clojure products, Datomic, and Clojure script. So the future of developers, a great programmer is going to need something from all these 5 languages. The other thing that is that you may want to consider is that Java does not have a REPL. REPL is a read, evaluate, print loop, and it allows you just to type in some code, test it out, and then once you get the behavior that you're looking for, take that code, paste it, and you're good to go. Now, as far as learning these languages, I know I have a minute, bear with me, I'll finish up as soon as I can. So how are you going to go about learning this? Well, Groovy and Ruby by far have the lower learning curves. Those shouldn't take you that much time. Java 8 is going to be, I think, a little bit difficult. It doesn't come too naturally. Clojure, if you're not familiar with Lisp, you're going to have to get through with that. Scala, I think, is going to have the highest learning curve. And for me, it took about 2 years just from reading books and trying things out. But I think it was well worth the mental investment. So how do you find time to learn these languages? Well, one thing that you could do is you can test. So use Clojure for your testing. Keep your Java, but use Clojure for your testing, or use Scala as your testing, or use Ruby. Use another language for your testing. That's not something you have to actually deliver to a customer per se, but it's one way to learn some of these languages, okay? That's one way to go about that. What I do is I do the Pomodoro Technique. And I know I'm out of time, I only have a few more slides left. Pomodoro Technique is a way to do tasks and stay focused on these tasks. What I did for Clojure this past year is I did 30 minutes, so that's a Pomodoro's 25 minutes with a 5-minute break. I did one 25-minute every day. I gotta tell you, that adds up. So on your venture now to learn these 5 new languages, take 30 minutes out of your day, consider it like a crossword puzzle, and you're gonna get far. You're gonna learn these 5 languages in no time, okay? So that's one way to learn it. The other thing is create your own language matrix. I created a language matrix for my very own. I have 10 now. It's still a work in progress, but I have C, Clojure, C++, Groovy, Haskell, Java, JavaScript, and this is my own personal library on how to do things. Create your own. Open up your own GitHub account or your own Bitbucket account and create something that is your own personal library on how you can compare and contrast these programming languages. So this is my personal knowledge graph. By far, I think I know Scala now more than I do Java. JRuby's kind of down at the bottom. I don't know too much about that. I'm hoping to use more Clojure in my daily life, but this is my 5 languages as we speak. Here's the culture of each language. Scala is a highly mathematical group, very nerdy, and some may scare you on words like monadic structures. The community is a mixed bag. You get some nerds that are kind of abrasive, but you also get some really great people. Clojure, a very highly functional group, Lisp-oriented, fixated on this homo-iconicity, where the code is data and the data is code. So whatever you get presented as far as the data, that in turn becomes the code. So you have this nice cyclical process, and it's great. They're focused on simplicity, which is a great thing. Again, they're focused on lists, sets, and maps. And community is extremely friendly. JRuby and Ruby, highly creative. You're gonna find that one of the most creative projects come from this realm. Very friendly after 2005. I think before 2005 they got a little ahead of themselves, but pretty much a good friendly group. But sometimes we'll press the bounds by often calling things that are dead when they're still perfectly alive. Java, best community ever. So if you're ever going to do reviews, I'll just go ahead and say that. But still very imperative. Java programmers had a lot of work to do to start thinking about their code in a functional way. So you still have that C++ frame of mind for those who are just stuck with Java. But again, they're always friendly. Groovy culture, the underdog culture, very powerful, concise, expressive language, a lot of great tools, and Netflix's secret weapon. Most of Netflix is Groovy, and they've been very successful with it. Here's my bet. Those are going to be the best 2 languages. And I think you're going to find those languages wonderful to work with. And in fact, as far as earning potential, I think this is where it's going to be. Just my guess. I could be wrong. It's up to you to prove me wrong. And I'll leave it at that. All right, thanks for bearing with the VGA issues before. And thanks again.